It's always good to start with a little review of the previous lesson before moving on to something new, especially when topics tend to build on each other. So in our last session, we were working on writing linear equations in slope-intercept form, y is equal to mx plus b. We found out that the way to write them depends on what information is given. When we're given the slope and the y-intercept, suppose the slope is equal to -4 and the y-intercept is equal to 2. We can write that equation very easily by replacing the slope and the y-intercept into the model. We then moved on to what happens when we're given the point and the slope. We had to first substitute in the values to find our y-intercept. And the last type we worked on in our last session was we're given 2 points, so we need to find both the slope and the y-intercept. Remember, we need those 2 key pieces of information in order to write the equation. A little practice. We'll start with the type where we're given the point on the line and a slope. So if we start with our model, y is equal to mx plus b, and we know that this is my x and my y coordinate, let's replace them because we need to find the value of b. 9 is equal to -4 times 1 plus b. All we did was replace the m, the x, and the y. We'll simplify. And one inverse operation will get us the value of b. b is equal to 13. Now that we know the slope and the y-intercept, our equation is simple to write. Y is equal to -4x plus 13. Let's just do one more of this type. We know that y is 11, m is -3, x is -2, plus b, our y-intercept. Simplify. Isolate by subtracting, and b is equal to 5. Once again, if we have slope and y-intercept, we have our line. Y is equal to -3x plus 5. We moved on to the third way to write the equation, and that's when we were given 2 points on the line. We needed to first find the slope. To find slope, we use the slope formula. Change in y2 minus y1 over x2 minus x1. We'll find that we have 40 minus 20 over 6 minus a -4, and that will give us 20 over 10, which is 2. Now we need to find a y-intercept. We can choose either point. I'll choose the first point. I'll then go into 20 is equal to 2 times -4 plus b. Let's solve for b. We'll add 8 to both sides. We get b is equal to 28. So once we have our slope and our y-intercept, we have our equation. Y is equal to 2x plus 28. Hopefully this little review was all you needed. If we want to see more, all you have to do is ask. So now let's look at a third type of equation, a form of the linear equation. It's called our point-slope form. Here is the model or the rule that we look at. Y minus y1 equals m times x minus 1. To be honest with you, I don't use this form very often, but it's good to recognize it and know how to write it. If you're given an x1, y1, and you're given a slope, you can easily substitute in. This just gives me y minus 3 equals a negative 1/2 x minus 2. That's all there is to it. You're just replacing in those couple of given values. A next example, I'm given an x1, y1. Y minus 4 is equal to 3 times x minus 1. Just practice a little bit here. Y minus 2 is equal to negative 3 x minus 5. There's only one little variation of this, and that's sometimes you'll encounter a negative coordinate. Let's see if I happen to have one of those to show you. And let's just go back. I'll create one of those. What if I had m is equal to 6, and maybe I had, let's say, sorry about that. Let's say I had a negative 2 and 5. Okay, this pen is acting up today. All right, so we have y minus 5. Once again, it's doing its own thing. Y minus 5 is equal to 6. Now this is x minus a negative 2. The only thing I have to do here, and you don't even have to do this twice, but you could say subtracting a negative just becomes a positive. So if you ever see that one of your coordinates is negative, one last one to illustrate this. If I have negative 2 and suppose I have 4, negative 3, I will then have y minus a negative 3 equals negative 2x minus 4. And again, I need to just rewrite this as y plus 3 equals negative 2x minus 4. We'll practice a few more in class, but that's all there is to point-slope form. And like I said, I don't find it as handy as slope-intercept form, and that's the one most of our focus will be on.